Yeah, hello everyone. Just a second. Good afternoon. So this is it will be just a couple of minutes. The reason for this talk is the following. It only concerns problems with SDP data. And the question can be, once you've heard the talk by Victor, what if I already have some SDP data in one of the popular SDP formats, and I would like to put them in my database? I would like to store them in JSON format, or on the other hand, if you already created some data in the JSON format, in the PMO format, and you would like to use some software which is not integrated in Julia, like the software CSDP. So how can I call that software to solve my problems? And for that, I wrote a couple of Matlab scripts, because Matlab for me is kind of natural language for SDP. SDP is about matrices. Matlab is also, it's a language of matrices. I'm considering SDP in the same format, so this min should be still in this blue rectangle, in the same format as Victor had. So a linear objective function, couple of linear matrix inequalities, and perhaps linear equations and linear inequalities. And I need one more notation here. This capital Y, those will be the dual variables for my linear matrix inequalities. Now, most or all standard SDP software like Mossack, SDP-T3, Sedume, CSDP, our SDP, SDPLR, they can read data in two most popular formats. One is called SDPA, which is data is stored simply in an ASCII file, and the matrices are stored in some sparse format. The other very popular format is Sedume, but this is Matlab binary, and it also includes data for other conic inequalities, like for SOCP. So we decided to base our tools on the SDPA format, more or less mimicking what is in SDPA. However, SDPA only includes the basic data, so the matrices, the vectors, number of LMIs, size of the problem. What we would like to include in our format is some more information, which is specific to polynomial relaxations. In particular, the fact that the dual variable can be of low rank. So you can say that it will be a low rank matrix of some unknown rank, or if we know the rank, then we can directly specify the rank, what it will be. And the other rank information is that often, this was already mentioned in Victor's talk, these data matrices are just low-rank matrices created by a direct product of two vectors, or a sum of these direct products. So this information should be included as well. Now, the SDPA format as such is not very Matlab friendly. A non-trivial reader is needed, and for that, so we created dedicated Poema Matlab format, where the data is stored in a Matlab structure with fields of the structure which are more or less copied from the JSON attributes, are identical to the JSON attributes, and the format of the sparse matrices is the same like the SDPA format. So to be more concrete, what we see here are the JSON attributes for SDPA format. So some of them were mentioned already by Victor. There are a couple of more of them. And what is in red, those are attributes which are specific for the Poema format, which are not included in SDPA. So SDPA only includes NVAR objective, so number of variables, the vector for the linear objective function, number of LMIs, matrix sizes, and the actual data matrices. So we have a couple of more attributes here. And which correspond exactly to the JSON. So those were the JSON attributes. And the difference between a JSON file, as we have seen it in the previous lecture, and the Poema Matlab structure is very small. So there are very few differences here. You see, this is the JSON file in the green color, and here in blue we have a Matlab structure. But then the fields of the structure, they are essentially the same. So type, NVAR, objective, and then all the constraints, they are stored in another structure, which is on level -1 of the original structure. And it includes number of linear matrix inequalities, sizes, possible information about the rank, and the actual matrices here. So here is the same example as Victor had, but without the linear inequalities. So we only have 2 LMIs, 3 variables, 2 LMIs of one of the size 3 by 3, the other of the size 2 by 2. The Matlab structure in the Poema Matlab format, again, it is very similar to JSON, it's just slightly different syntax. So we have to say that the type is SDP. Number of variables is 3, 1, 2, 3. The objective function is again 1, 2, 3. The vector of length 3. Then the constraints are stored in that structure where the number of linear matrix inequalities is 2, the size is 3 and 2. And here we have all the matrices in the sparse format. For instance, the 0 matrix, so here we have the constant matrix, which is like 0 matrix, and the 0 is on this position. The values, we only store the upper triangle, the values are 1 and 2, and these are, it's for the second matrix inequality, that's the number 2, and these are the indices of coefficient 1, and these are the indices of coefficient for the number 2. And the rest is the same. So this is exactly like in SDPA. The only difference is that in SDPA, the first column is the last column. So here it's put in the first position. And okay, so if you code this in Matlab, and then if you type in Matlab SDP1, this is what you get as a result. A structure with these fields, and one of the fields is yet another structure. Okay, so the good thing about this Poema Matlab format is that it is more or less identical to the JSON format. It's easy to edit or add attributes to edit the data because everything is an ASCII file, so that's nice. The not so good fact is that it is an ASCII file. So if you have big problems with large data matrices or with very many variables, the ASCII file will become huge. So you may easily get file with of size of gigabytes. And that's why we added one more format, which is based exactly on the same structure of the data, but the matrices are now stored in sparse Matlab format. So all data are stored in the Matlab structure again, but the sparse matrices and sparse vectors are converted to sparse Matlab arrays. So here's an example. In blue, that's the ASCII format, Poema Matlab format, and on the right-hand side, we have the sparse format. So we see that the first fields are exactly the same, type, NVAR, name, comments, objective. But now we don't have a special structure for the constraints. Everything is our fields on the top level of the big structure. And in particular, the matrices are stored as cells in sparse Matlab format. So in particular, if we want to have a look at that matrix, and this constant matrix 0, 1, 1, 2, so in the Poema Matlab format, it would be stored in the first 2 rows of this structure as the one constraints by CMAT. But in the sparse Matlab format, it would be stored as a 2-1 cell of the array of cells SDP1.A. This way, the data will become, or the data files will become much smaller. Now, for all that, you can find 4 Matlab scripts or functions. You can find them in the same GitHub page under the subdirectory Matlab suite. So there you can also find the this tutorial. And what do we have here are 4 Matlab functions for translation between JSON and Poema format, translation from Poema format to sparse Poema format, and in addition, we have files for functions for translation between SDPA and Poema. So from Poema to SDPA, or from SDPA to Poema, in case you already have data in SDPA and you want to translate it into Poema format. Of course, the SDPA format does not include the information about low rank matrices, if there is any such information. So this will be simply ignored in this translation from Poema to SDPA. But what you can do, if you have data in SDPA, you can read it into Poema format. And if you know that some of the dual variables are supposed to be low rank, then you can, in the Poema file, you can add these attributes in the ASCII file. So, for instance, in our interior point code, which is all written in Matlab, we read SDPA files in this way. Using SDPA Poema, I simply read the SDPA file. This will be, D will be this standard Poema structure, not the sparse one, and then I will translate it once again into the sparse structure, so that then, for instance, the IJ matrix, the data matrix, will be in the structure D as D dot A IJ plus 1, because we have it shifted by 1. Right, so those are the 4 functions, and in the end I have one exercise, but for that I would like to switch to my Matlab screen, and I hope it will be, the fonts will be big enough. Okay, so is it big enough? Is it readable for you?
I think it's a bit small. Can you make it bigger?
Is it bigger now?
No, it's smaller.
And smaller. So is it better now? I tried, this is a live editor in Matlab. I tried to change the fonts, but I just don't know how to do it. I can change fonts in all other windows, but not in this one. Anyway, so I will try to go through that. This is a Matlab live script. You can find it in that GitHub directory. You can also find a PDF version of this script. So you can Maybe I can give you a couple of seconds to open it if you like. What I want to demonstrate here is basically how to translate files or data from one format to the other format. The key information is here on the top, so maybe I can try at least to extend to make this one bigger. This is even worse. Okay, this seems to be the biggest font I can reach. The fact is, it says that if you want to translate between JSON and Poema, so from Poema to JSON or from JSON to Poema, you need to download a Matlab tool, which is called JSON Lab, which is not coded by us, so I just downloaded it from Matlab Central, so it's one of the shared tools in Matlab community. And once you have this, and also these the two codes I presented before, the two functions, Poema to JSON and JSON to Poema, they actually called functions from this JSON lab. Now, let's say I have written that example in a Matlab file. Let's call it x1. This is the content of that file, SDP1. Well, it's a structure which is called SDP1, and it's exactly the same structure we had before. So I just call this x1 file or script. What I will get is this output here, that it is indeed a structure with the following fields. If I want to translate it to JSON, I just say save JSON, and SDP1, that structure will be the second argument of that. Let's do it. What I will get is a JSON file, and you see again it looks pretty much the same as the Matlab file, just the syntax is slightly different. Now if I want to store it, I just open a file, it's called myfile.json in Matlab. I will print it there, and if I look in that stored file, indeed it is exactly the same as we have in Matlab. Then if I want to read it, then again I just use the command file read, which is yet again command of JSON lab. So file read, my file JSON, so I will get again SDP JSON, which is yet again my, file read is of course Matlab command, load JSON is the JSON lab command. So I will load JSON back into Matlab structure. So here is the structure I started with, going through JSON and back. The function Poema to SDP, okay, it has two variables, the name of the Poema structure and the name of the output file, because it will be directly written in the output file. If I use the same structure, x1, so my structure named SDP1, and I use the command Poema to SDPA with SDP1, write it in the file, my SDP file. Then, okay, it's written, and the SDP file looks like that. And you see a number of things are, all the attributes, the names of the attributes are not there because SDP just assumes it will be on the line 2, or something will be on line 2, something else will be on line 3, and so on and so on. So this is standard SDPA file. And if I read it back by SDP to Poema, I will get back my SDPA structure. but now it will be a little bit, there will be a little bit less information because some information is missing in the SDPA file, and also the name of the structure, which originally was my first example. Now the name of that structure will be the same like the name of the SDPA file, just to see where I got this file. So I thought it would be better to give it this name. And okay, the final command here is the poema to sparse. Well, that's pretty easy to use. I have my SDP structure in the poema format, poema Matlab format, the non-sparse one. I call poema to sparse, and what I will get is the sparse format. So for instance, here is the matrix A21. Again, that's the constant matrix for the second LMI. And you see this is the sparse Matlab format of that matrix. Okay, so that's all from me. Again, you can find all that in on the GitHub polynomial moment optimization /MATLAB suite. Any questions?